Okay.
Jake, are you there?
Is Jake there? We
Here.
see a wizard.
Jake,
Oh, hey!
Hey.
There's Jake.
Hi.
Now, can you zoom in on my name, Cora? Are you zooming in on my name there? Oh, look at there. I'm Jake.
Everybody pin Jake's video, okay?
Can y'all see Jake? That's my name, Jake. I'm Jake. I'm a wizard. Whoa. Hey,
Oh.
is there somebody there named Eli? Is that right? Eli? Hey, Eli. I made, oh my gosh. Look at all these names. I mean, I've got a guy named Kingston. I don't know who in the world's named Kingston. I don't know, I'm just saying. There we go. Goodbye, Kingston. I'll do that. Man, I've got a whole list of people. You know, I'm a wizard. I'm wizard number 4. Everybody say hello, Jake.
Hello, Jake.
And I'm coming from about, I don't know, 5,000-6,000 miles away from you right now. And I'm in a place called Faraday Studio. There have been wizards here for 200 years. I'm wizard number 4. Hey, can we show them around? Do we have a video of the studio? Let's watch this little video, and I'll show you where I'm coming to you from.
We have to load it up, Jake.
Okay. Well, I'll go. While we're loading it up, I'm going to burn Samantha's name here. Whoever you are. Woo! Sweetness. Matter of fact, I made this before you came. Just while we were waiting, I made this. It's called flash paper, and I took some paper and I added oxygen to it in a chemical form, and I added more oxygen atoms in here. And so instead of burning normally, Lettice, let's say goodbye to Lettice.
Goodbye.
Woo! She was fast. Lettice just landed on my leg. Burn a hole. We'll try. Yeah, are we loaded up? So, okay. Say goodbye to Oliver. I'm going to burn Oliver's name too. I don't know. There, that was a good one. I want to show you around the wizard's laboratory. So let's watch a little video, and I'll tell you where we're at. Oh, here we are. This is inside my laboratory, and this is where we teach young people to think like a scientist. We sharpen the skills. I don't know what that's setting up there on the desk. And there's Michael Faraday right there. That's the real Harry Potter. There are the 4 wizards. And Michael Faraday was the real Harry Potter. And there's Robob, my robot. And that's my laboratory. And I'm sitting down here somewhere. London, okay. So that's what it looks like around here. And we've been doing this since 1795. So it's over 200 years, about 225 years. I don't know what that is. Oh, that's flying around the studio, yeah. So,
Brendan, stop it.
yeah, and there I am. There I am down here and I've got an airplane flying overhead. Oh my gosh, in my studio. So what I thought I would do today is do some activities that Michael Faraday, wizard number 1, did in the year 1817, 203 years ago. And he was trying to get young people your age to think like a scientist. So here's the first activity he did. Now I want you to watch what I do. Oh, I got another piece of paper. I got to get rid of all these pieces of paper. Is somebody out there named Max? Do we have a Max? Hey, say goodbye, Max. Sorry. We got to let Max go. Bye, Max. There he goes. Whoa. Nope. Well, I just set the carpet on fire. So this is an activity you can do at home, and it will teach you to think like a scientist. Now, I just found this round thing. I think it's a bowl. But you can find anything smooth in your house, like a spoon or a ball or something smooth. I just want to get something smooth. And I've got a yardstick, a meter stick, and I'm going to balance it right on that bowl. Like that. See if I can get it to balance. Yeah, there it's balanced. And nothing's touching it right now. But I want to see if I can make it move without touching it. And the way I'm going to do it, I'm going to take a balloon. How could I make this thing move without touching it? I don't know. You got to think about that for a second. So I'm going to take a balloon, blow it up. And you don't have to have a balloon. Anything made out of plastic will work. A comb, an old milk bottle, it's made out of plastic, an empty 2-liter soft drink bottle. I just like to use balloons. And I know it might be hard to do in Hawaii because it's a lot of humidity in there, but I'm going to put a static electricity charge. I'm going to put electrons on the outside of this balloon. And some people can do that by rubbing it on their shirt, like that, or rubbing it on the curtains. I'm going to rub it on a piece of fur. I think this used to be my cat. I don't know, Fluffy the cat. I've got some fur, and I'm just going to rub this balloon on the fur. And when I do that, it puts some electrons, a static electricity charge on the balloon. And if everything works well, that charge will be strong enough to move this stick. Are you ready? Let's try it. Let's zoom in on the stick there. Here we go. I'm going to bring it down. And, oh, did you see that? Now, I'm not touching that stick, but I'm making it move with this static charge. See if I can get it to go back the other way now. I better put some more charge on there. See if I can go back this way. Oops, there it comes. Ooh, there it goes. Isn't that amazing? Now, I'm not touching that stick. Well, I am now to get it balanced again. But you could do that at home. And it doesn't have to be a yardstick. You might find a great, big, long board. And if you balance it, you can take just a little bit of static electricity and make it move. And I can do it with a 20-foot long board. The same thing. Ooh! And I was able to move that. Oops, I just hit it. So what I'm going to ask you to think, have you ever seen in your life static electricity affect the motion of something? And you just think about that. Have I ever seen this before? Let's go do another activity you can do at home. That was one you could do at home. Let's do another. Where am I going? Oh, I'm going over here to the sink. Let me go over to the sink, over here in the laboratory. Okay. Now, I know you've probably done this before. I've got some vinegar and baking soda. You've probably done this before. I'm going to put a little baking soda in a cup or something. Doesn't matter what I put it into. Put a little baking soda in there. And a little vinegar. Vinegar has some acid in it. It's called acetic acid. That's why it makes it taste so bitter. It's just sour. It's got some acid in it. And you watch what happens to the baking soda. And you've probably seen this before. I'm going to pour a little vinegar on top of the baking soda. And, oops, it's foaming up. It is foaming up. And all those bubbles, and that's called effervescing, by the way. It's a fancy name for bubbling. Giving off a gas called carbon dioxide. And those bubbles, that gas, are filling up this beaker with carbon dioxide. It's a heavy gas. And I want to show you something interesting about carbon dioxide. If I light a match, I'm going to light a match right here. And the match is burning, and it's combining with oxygen in the air. But down inside that beaker, there's no oxygen that we breathe, the air that we breathe. There's carbon dioxide. So I'm going to take this match, and I'm going to stick it down in there where there's no air, no oxygen. Because there's carbon. What do you think is going to happen to the match?
Not going to be lit anymore?
I don't know. They're
Might blow up, huh?
might blow up. Well, let's find out. In case I have an accident, everybody say goodbye, Jake.
Bye, Jake.
Bye, Jake. Here we go. I'm going to put it down in there. Oop, what did it do? It went out. Let me do that again. That match went out when I put it down in the carbon dioxide. And you can make some carbon dioxide at home. Just do it in a sink. Do it in a bucket or a bowl. And you can put some carbon dioxide. Look at there. That thing is full of carbon dioxide. Watch what happens when I lower the match down in there. It went out right there. Isn't that amazing? But here's what's really fun to do. Is I'm going to take this jar. And I'm going to pick this thing up. And I'm going to pour carbon dioxide into this empty jar. Watch this. It's like I'm pouring it in. Guess right here. And that carbon dioxide is going in the jar and pushing all the air out. So now I've got that jar full of carbon dioxide, and I'm going to put a lid on it. Right here. So there it is. A jar full of carbon dioxide. Can't see it in there, but it's in there. And you can put it up on the shelf and leave it there for a long time. Now, what in the world could you do with a jar of carbon dioxide? What could I, if I had this jar at home, what could I do with it? I have to think. What could I do with a heavy gas that does not let things burn in it? What could I do with it? Well, here's one thing you might be able to do. I've got some candles here. Next time you have a birthday party, and I don't know how many candles I'll light. I'll light a couple more. Yeah. Here's some candles right there. And I'm going to light them like on a birthday cake. So I light these. And gosh, on my birthday cake, how many candles do you think would be on my birthday cake?
100.
Whoa, 100.
100.
A million and a non-stop.
That's what I'm saying.
72.
Oh, who did? Who said that? I like that girl. So now I've got 6. But I could do this with a lot more. And I think you could do this at home. It'd be a fun trick to play on your family or friends. So you can take a jar of carbon dioxide gas, and it's heavier than air. It's going to go down. It's more dense. Are you guys zoomed in on the candles? You zoom in on the candles. And I'm just going to pour the carbon dioxide out of the jar onto those candles. This could be a birthday cake. Okay, there wasn't any in there. I must have left that one empty. Sorry. Yeah, there it went. You see that? Sweet. So anyway, you can make a jar of carbon dioxide, put it up on the shelf, wait until your birthday, and when they say blow out the candles, you can say, oh, hold it. I'm going to pour out the candles with my carbon dioxide gas. Let's do another one you can do at home. Let's go over here to this table. Remember, that was made with baking soda,
Baking soda and
vinegar. There's some baking soda. It comes in a box. It says baking soda on it, you know. Got it at the grocery store. Oh, this is a fun one. I've just got a little pan filled with water. This is just regular old water, nothing special about it. No. And I got some cards, a little piece of cardboard, thin cardboard, and some scissors. And I cut out a boat. I made a little boat. And here they are. Can you see the little shapes that I made? Zoom in on that. Is somebody zooming in on that? Oh, right there. Look at this little shape that I made. Looks like a little boat. And I cut, let me point to it. I made a little hole in the center. And then I cut a little slit right there. So it kind of looks like a little boat with a slit there at the back. Right there it is. And I'm going to take some of my boats and float them in the water. Okay? But I want to try to get them to move. And how could I get let's see if I can get one to float first. Oh, there he is. He's floating right there. Go. Go. Whoosh. What could I do to get that boat to move?
not moving, Jake.
It's not moving. Well, I probably need to put a motor in it, something to make it move. And what I'm going to use is some soap, some dishwashing liquid. This is some blue dishwashing liquid, and I've got a little bit of it in this little beaker. This is just soap like you wash your dishes with. And I'm going to take this boat that I cut out of paper. I'm going to lay it in there. And I'm just going to take a little drop of that soap. Just the tiniest little drop. And I'm going to touch it right there. There it goes. She's taking off. Let me give it a little more soap.
Oh.
Oh, there it goes. Try up. He's going around. Let me try another one. I think my soap dried out a little bit. So let me put a little water in here. My soap kind of got hard on me. Look at that go. There it goes. Man, I can put soap in there and make those things fly. There she goes. She's flying. I'll try it with a toothpick. You're going to have to experiment with different types of soap. You say, why would soap make this thing go? I don't know why soap. Oh, there, I dropped that soap. Oh, look at that one go. He's going now. Ooh, I could do this all day. Try another one. Oops, I sunk that one. Had an accident there. I just drowned everybody on that boat. Look at that one's going crazy. So I want you to think like a scientist. Oh, look at that one go. Hee-haw. He's a good one. Look at that thing go. Well, I don't know if you've ever poured water out. Who am I talking to over here? You ever poured water out? You'll notice when water gets poured out, it puckers down into little balls like drops. Water tends to pull on itself. Water pulls on itself and makes drops when it gets poured. Water does that. If you ever spill some water, you watch it, it will pull together and make a little drop. Water molecules are attracted to each other. And it's actually not the soap that's pushing it forward. It's the water in front that's pulling on that. It's actually the water in front of the boat that is pulling it forward. And the soap is just keeping the water at the back from interacting with the back of the boat. So really, the soap doesn't push the boat forward. It's water that pulls it forward. So you can play around with that. Just get some paper or a little thick card stock like that and cut it out in any shape you want. You can try different shapes. And just make a little spot at the back to put some soap in. And you make a soap boat. One more. I'll fire this one up, see if I can make it go good. Whee, doggies. Ah, you're dead. Yeah, that boat didn't work too well.
Ain't moving.
Yeah, he must have been made in Kansas. Look at that one go fast. No, he didn't go. Okay, enough of that one. You can try that at home. Do we have time for another one?
That's time? One more?
I think so.
I think so. One more, Jake.
One more. Okay, let's go back over here. Let's go back over here. This one's just kind of fun to see. I've got, I like to end every presentation with something really neat. I've got inside this pouch a pickle. Yeah, I'll lay that right there. I've got a pickle. Doggies, just a regular old pickle. Yeah, that's an old dill pickle. And do you know where pickles come from, by the way? Does anybody know? Where do you find pickles? Anybody know where pickles come from?
Cucumbers.
Cucumbers. That's good. Who said that?
Me.
Me? Okay, that's good. Well, I tell you what. Oh, yeah. Well, it used to be a cucumber, but we soaked this cucumber in vinegar and salt to turn it into a pickle. This used to be a much bigger cucumber, and we put it in salt water. Have you ever been in the bathtub or in the swimming pool or out in the ocean too long, and you look at your hands and they're all wrinkled up?
Yeah.
You know? Yeah, you get wrinkly like that.
Yeah.
Yeah, that happens. Well, that's what happened to this pickle. That used to be a cucumber, and he soaked in the liquid way too long. But
Pickle fingers.
Yeah, pickle fingers. So I'm going to do something special with this. I'm going to run some electricity through the pickle. I wonder what would happen if I ran electricity through a pickle. I want you to think about it because you're thinking like a scientist. What would happen to a pickle if you ran electricity through it? So I'm going to lay the pickle right here. And here I've got an electrical outlet, and this is kind of dangerous, so you don't want to do this unless you've got some help. And I've got a cord, an electrical cord. Boy, this is dangerous, so we have to be careful. And on the end, I've got an end that plugs in, so electricity will come in this plug. And then I've got 2 wires here. And on the end of each one of those, I have a little fork that I got in the kitchen. So what I'm going to do is plug this in and stick the forks in the pickle. So let me make sure it's turned off here. It's turned off, okay. I'll set it there because I don't want to turn it on yet. See if I can get this to plug in, okay. So I want to stick one fork in this end, and I'll stick the other fork down here, like that, right there. Okay. And I'm going to turn on my safety switch. In case I have an accident, everybody say goodbye, Jake. I'll hold that up there. Bye, Jake.
Bye, Jake.
Bye, Jake. So I'm going to, bye, Jake. I'm going to turn it on, and we'll run 110 volts through the pickle. See what happens. Ooh-wee. Look at that thing spark. Well, that's sparking because all the salt and vinegar inside the pickle conducts electricity. Now you can say you've seen an electric pickle. Okay, I'll shut that off. All right. Let's give that pickle a hand. Yay, pickle.
Yay, Pickle.
I'm going to head back over here. So if you liked what you saw, we do, here at Faraday Studio, we do activities like this all the time, hundreds of them. So you come join us at Midnight Science Club sometime, and Mel and Lisa will tell you how to join Midnight Science Club, and you can see these activities all the time. Hey, Wong. I'm going to say goodbye, Wong. Woo! And Apollo. Oh, I love the name Apollo. This is sweet. What a name to live up to. And Micah. That's an awesome name. Oh, he went up. Good for you, Micah. Stephen? I like that name. That's a real good name. I know a handsome man, neighbor of mine named Stephen. He's very good looking. Oh, yeah, Stephen did great. Got a couple more. Are we doing all right, Melanie?
We're doing good. We're good.
All right, Kendrick, I'm going to say goodbye to you.
Bye, Kendrick.
And I saved Max for last. I'm going to say goodbye, Max. You going to smile for me, Max? He's going to sit there. There's that smile. That's what I was looking for. Oh, he disappeared like that.
Great job.
All right.
Thank you so much.
Hey, thanks for letting me join your workshop. I enjoyed this.
Yes. We'll do it next week again, all right?
You tell everybody you saw a real wizard.
Did everybody like Jake today? Was it cool?
All right. Thank you, Eli. Latisse.
Thank you. Thank you.
Stephen, you're a handsome man, Stephen. Max. And
All right.
see ya. Bye. Bye. Joshua.
Next week, right?
All right. We'll see you next week. Bye.
Bye, Jake.
Bye.